In this video, we will look at the branch and bound approach to solve the computational problems. The branch and bound is also one of the problem-solving approaches which uses state space tree to systematically search a solution. This strategy is like backtracking approach. However, backtracking algorithms are distinguished by the way in which the possible solutions are explored. That is, backtracking strategy uses depth-first node generation to find the solution. In branch and bound approach, we use the same tree organization known as the state space tree. But unlike backtracking, the branch and bound searches the tree for the solution in either breadth-first search manner called FIFO search or depth search manner called LIFO search or least cost manner. The bounding function is used to kill the nodes that do not lead to a solution. The common state space tree organizations are either subsets or permutation trees, same as what is used in backtracking. The branch and bound approach is used to solve the minimization problems. To have a better understanding of the branch and bound strategy, let us look at the state space tree organization. All the nodes are problem states. The edges have labels representing possible xi values. The branch and bound strategy differs in the way E node is expanded. An E node is a live node whose children are currently being generated, and the live node is a node which has been generated and all of whose children have not yet been generated. In branch and bound, each live node becomes an E node exactly once. We start with the root as the initial problem state, which will be the live node and becomes the E node. When a node becomes an E node, all new nodes that can be reached are generated. That is, all the children of the E node are generated. Then all the newly generated nodes become the live nodes. So all the children of the E nodes are generated before any live node can become an E node. Then the nodes that cannot lead to a solution are discarded. The bounding function is used to kill the node and avoid generating subtrees that do not contain an answer node. A dead node is a generated node that is not to be expanded or explored any further. The remaining nodes are added to the list of the live nodes. Then the next live node becomes the E node and is expanded. The process continues until either the solution is found or there are no live nodes remaining in the state space tree. There are two ways to select the next live node which will become the next E node. One way is to use the first in first out scheme, which selects the live nodes from the list of live nodes in the same order they are inserted. That is, the list of the live nodes behave as a queue. The selected live node becomes the E node. And the other way is to use the least cost scheme, which uses a cost associated with each node. The live node is selected from the list of the live nodes based on the least cost. To use this scheme, a min-heap is used to store the list of the live nodes. The selected live node with the least cost becomes the E node. So this is how the branch and bound strategy works to find the solution to a problem. The difference between branch and bound and backtracking is the way the nodes are generated. The branch and bound strategy works on breadth-first search manner, whereas the backtracking works on the depth-first search manner. In branch and bound, every live node becomes the E node exactly once, whereas in backtracking, a live node may become an E node more than once. The branch and bound strategy uses FIFO or least cost when selecting a live node which becomes an E node. So it uses queues or heaps to store the live nodes, whereas in backtracking, live nodes are selected using last in first out manner. So it uses stacks to store the live nodes.